Hello, everybody, and welcome to another episode of Analytics Mindset. This is another entry for database basics. In this case, we will go through granularity and grouping with SQL Server. As always, if you are not familiar with SQL, I have a whole series of database videos that you can watch and get familiar with, and it's going to be somewhere over here in the screen. With that being said, I will be using the same dataset that I have used in previous videos. I will not explain that dataset a lot because we have already seen it multiple times. We will start by looking at this houses data. This is the same dataset that we used before, and I will execute this to create a table. We will use multiple techniques to aggregate and get reports that basically take the whole table and concentrate it and give us a summary on what is happening, as well as saying some of the uses around there. First, we will insert our data. As you can see, it's very similar to the previous videos. However, I have added more values, yes, to have more data in the reports and have another set of values to play with. You can read these columns if you want and what are the descriptions, but again, all of this is just data for some houses that I made up. Mostly, if you're working for a company or you're working in a project, you will be given data, and the interpretation is up to mostly you and the business concept. Let's start with just doing a select star from houses. As you can see here, you're gonna have 14 records in this case, and there is some null values. We will not worry that much about null values in this case, though SQL has ways of handling null values for sure, but they are not really that important for this video. Let's get a simple, something simple that actually SQL Server Management Studio gives us the actual count of records. How many records are in this table? In SQL, you can do this by using select all from houses, but with a count. We are counting 14 records. What this is doing is taking all the records that we had here, and then it's counting. Okay, how many records do I have where there is some value given all these columns here? And recall that select star is just a shortcut for select every single column. So this syntax is the same as saying select owner ID, street, state, price, price date, year since construction, down payment, and year since renovation from houses. Now, what if we only want one column? We only want to see how many owners are there. 13. If we go back here to houses, you can see that there is indeed 13 values, but a lot of them are duplicate. We don't want duplication. It's fine if there are 13 records that are counted as owner ID. However, for practical purposes, that's really not going to benefit us at all. That's where you use a distinct keyword. We can use a distinct keyword in order to get the distinct count of values for the field. As in this case, I'm going to execute this. And as you can see, I have 4 different values that matches up with what I see here. I only have 1, 2, 3, and 4 as my owner IDs. Now, if I do this again, you're going to notice here, very similar to our previous video on the where clause and how to do case when to get derived fields. There is no column name here. It's just going to tell me no column name. If I were to export this to Excel or to anything else, it would be a problem because then I don't know what is this. I don't know where it's coming from. We can use the keyword as to give it an alias. As you can see here, I'm saying select the count distinct of owner IDs and then name that number of distinct owners. Now I have a column name called number of distinct owners. The reason why this is happening is because I am taking owner ID and similarly to how we did the derived columns before with case when, this is creating a new column. That's why it doesn't have the same name as the previous column that we just used. We are going to demonstrate some other functions in SQL, and we are going to use things like sum. Here, for example, we are just adding the down payment to get the total down payment and adding the price to get the total price here. As you can see, these are just sums. I am just adding together all the down payments in the table as well as all the prices in the table. Min and max are pretty self-explanatory. You're giving either the minimum value of a single column or the maximum value, and you can get the range too if you were to use some functions. I let the range exercise as a homework if you want to challenge yourself. But as you can see, this is the minimum price from the table, and this is the maximum price. Average gives us the average of a column. Again, pretty self-explanatory. I'm just selecting the average price from this table, and then I'm taking that from houses. Now, recall something. We have been doing all these aggregations in the whole table. The whole table only has one number that describes the whole aggregation. In this case, we have two columns that have been aggregated, but it's still only for one single value for the whole table. It's giving one column and compressing that into one single value that is going to define us the whole table. What if we want more granularity? We don't want just the minimum price for the whole table. We want to know maybe by state, for example. That can be done very easily in SQL with the group by clause. The group by clause is going to allow us to say, take me the minimum price, maximum price, and average price for these columns. However, do it by state. Only give me each value by state. As you can see, we have different values per state here, and these are the minimum prices, maximum prices, and average prices. However, notice how here we don't have a label. We only have the actual values. They are correct, but we don't have any label. We cannot know which state this is going through because there is no way to know. You can guess, but that's not useful for sure. Fortunately, SQL has a very easy way to do it. We just need to add the label back. How do we add the label back? We include it in the select clause. In this case, you have the minimum, maximum, and average, and then you put state. You are grouping by the state. Yeah, that's what group by is what's helping calculating the values. But putting back the state label allows you to display it. Same report as before. However, now we know which single state was used to calculate these values. Now we can use the where clause to filter as before, and this happens before the aggregation. So we are filtering the values here before it actually goes into the aggregation, and this will be important later. If I do this, you can see how I am only getting the results for California, Florida, Georgia, and Texas. And that is in purpose. I am filtering the values first for state in these states, and then I'm passing that into the aggregation. That means that if there were other states, they are not going to be calculated, and therefore that should speed up the query a little bit. This is not noticeable right now because this is a 14 record table. However, if I were working with a table that had thousands of records, hundreds of thousands, and millions, you might see a difference if you do the where clause beforehand, because you're filtering values coming into the table before they actually hit the table. The other way to do this is with the having clause. We could do the same way. However, I am not going to do it because it would be silly for this example. Instead of that, I'm going to do by the mean price. Now, pay attention to this. If we execute this only without the mean price being more equals to 1 million, we get every single mean price here. This has been already been calculated. Having will allow us to use mean price and then filter that mean price by 1 million after this has been calculated. After the aggregation has happened, you can use having to filter that value. And as you can see, all of these minimum prices are more than $1 million. And the last thing we're going to do is drop the table houses. With that, we are done with this tutorial. I know this was a short tutorial. There is a lot more you can do. However, this did overlap a little bit with the case-when statements because, as you can see, a lot of these aggregations are just case-whens built into SQL. I'm basically saying, give me the minimum value of price and then make another column separate from the main columns here. Because of that, really, you can do all the stuff that we did in the previous video. such as creating CTEs, common table expressions, or you can also do a subquery. Now, it gets a little bit tricky with subqueries and CTEs, but the point here is that you can do a lot of transformations in the SQL pipeline. If you have an in-database connection, this can speed up your analysis a lot. You can perform a lot of different aggregations in the database before your ETL pipeline goes into any external platform. That is going to help the speed a lot, and also whatever tool you're using to visualize this. If you're using one, there is connections straight from SQL to Excel, Tableau, Power BI, etc. This will allow you to reduce the processing time of your ETL pipeline because this is being done in database with SQL instead of doing it anywhere else. And with that, I will stop here. I really hope that this was useful for you. Please leave a comment, leave any feedback that you may want to give me, and I hope to see you later. Thank you. Bye-bye.